Hello everyone and welcome to another video on how to use the powerful ArcGIS Pro. In this video, you will learn how to create a geodatabase with featured datasets and featured classes. Learn how to create domains for the attributes of our tables. We will also learn about the select by attributes and the select by location tool, and how to use the Planarize tool to make our work fast and easy. So, the first thing we're going to do is to save the project in a folder. For that we go to location, desktop, click right there, desktop, create folder, give it a name, YouTube tutorial in my case, not tutorial but tutorial. I will click OK and I will give a name to my project, tutorial. The first part is done. So now, as I said in the beginning of the video, we'll start by creating a geodatabase where we can store our data. So for that we are going to click on View, Catalog panel to open the catalog, and we are going to here on Folder, right click, add the folder connection, and we will select the folder we are going to work with. So the folder we saved the project in the beginning. Click OK, and the folder is connected. To create the geodatabase, you click with a right click on your folder, go to New, File Geodatabase, give a name. I will give a name of tutorial, and that's it. The geodatabase is created. Every geodatabase needs to have a feature dataset. What a feature dataset is like a new folder inside the geodatabase. For example, for this feature dataset, I will name it parks. I will create feature classes that are only corresponding to parks. So we do this to divide several types of data and to make our lives easier when we have tons and tons of feature classes or other types of geographical data. I will create a new one just so you have an example of what I was explaining. So for this one I will call it urban areas, and if needed I could create feature classes related to urban areas inside this dataset. For example, buildings, streets, traffic lights, or other types of urban elements. This was just an example, but now let's create feature classes inside the parks feature dataset. To do that, right click in the feature dataset, New, and select feature class. As you can see, inside the feature dataset you can add different things like relationship classes, topology, network dataset, that actually I will do a video about it very soon, or even parcel fabric. For today we select feature class, and we can have different types. The most used are points, polylines, and polygons. But for this one, let's select lines and name it pathways, for example. We'll leave the other selections as default. Click next. For the fields, we will add fields later. Next again, coordinate system set as default. And we don't need to change anything else. Now let's repeat the same steps, but this time I will name it as playground and select the polygon type. We don't need to change anything else, so we can go next and finish. Do the same, name it as trees and points as the type. So we already have the three feature classes imported to our project, as you can see here in the table of contents. So let's open the attribute table of this one. As you can see, we don't have any fields in this table, but before we add any fields, let's start by implementing attribute domains. Domains are simply available values we can have in a field type, and this is used mainly to avoid different values in a field, like same names but with upper cases or lower cases, missing letters, or even blank spaces. So when a feature class has domains, the user doesn't need to type the value, but instead have a list of pre-chosen values. Let's close this table. And to create domains, simply right-click in the Geodatabase and select Domains. For the domain name, I like to start by typing a lowercase d, meaning domain, and then the name of the domain. Then if you have a list of a lot of domains, maybe it should be better to add a description. For the field type, maintain text. Domain type set as default. Split policy, select duplicate. Later I will explain what this does. And merge set as default. Here for the code, I will type acronyms of the type of surfaces I will create in my list. For example, CB for cobblestone, DT for dirt, GR for gravel, ML for mulch, CN for concrete, PV for paver, and OT for other type of surfaces. The next domain name will be a boolean, where 0 will be equal to false and 1 will be equal to true. So for this one, change the field type from text to short and set the others as default. For the code type, choose 0 for no and 1 for yes. The last one will be about the preservation of the pathways. For this, we will have a scale from poor preservation to good preservation. I will name it as D preservation. The field type will be text and just change the split policy to duplicate. For the code, I will type 1 for poor, 2 for medium, and 3 for good. Click on Save in the top left corner and close the window. Now what we need to do is to create fields that will have this attribute domains we just create. For that, I will open the table of the Pathways feature class and start by creating some fields. After the table is opened, select Add to add new fields. The first one I will name it as surface. The data type will be text and choose the domain of the surfaces. Don't forget that if the field you are choosing is the text type, the domain must also be text, okay? So therefore it's impossible to have a field that is text type with short or double type domains. The next fields will be walk, run and cycle. These will indicate whether the path can be crossed by walking, running or cycling. The data type will be short, and for the domain we will select the boolean. So 0 for paths that cannot be crossed by walking, running or cycling, and 1 for the ones that can. The last field will be about the preservation of each path. So name will be preservation, text in the data type, and depreservation for the domain. And this time I will select medium as the default value. So what this does is that whenever a line is created, this field is automatically filled with medium preservation. Click on Save and close the Fields window. Now let's create some paths. For that, let's try to find an urban park. Let's try here in Denmark. Here, for example, no, it's not a park. Maybe up north a little bit. No. Let's try Aalborg. Yeah, this one. We stick to this one. To create an element, go to Edit, Create, select Pathways, and start drawing. Let's start here. After you finish, just double click on the mouse or hit F2 in the keyboard. As you can see here in the table, the preservation was set to medium as the default value as you specified. Now let's select gravel right here. This path can be crossed by walking and running, but not in a bike, okay? So I'm just guessing, I've never been to this park. Select medium in the preservation. Important tip, always remember to activate the snapping tool, okay, right here. What this tool does is that when you are making edits, you can easily understand where the limits of other elements are, such as vertices and edges, okay? Now I will create 2 more lines. For example, this one. The surface will be maybe concrete. It can be crossed by walking, by running, and by cycling. Preservation of this one is good. Let's draw another one. Maybe this one a little bigger compared to the other two. Okay. Clicking F2. The surface is concrete. It can be crossed by walking, by running, and by cycle. And the preservation is good too. Okay, if you remember, when we were creating the domains, in some of them we left the split policy as duplicate, okay? So when choosing duplicate, whenever we separate a line that has already been completed, the field with duplicate in the split policy will remain on the new line, okay? So for example, if I go to Edit and select Split and click on the selected line with the mouse, this feature will be divided by 2, and the field where the split policy was set to duplicate will remain, and the others will be set to the default value. So in this case, only the surface field and the preservation field remained unchanged. Let's fill this again and merge the lines back. So for that, go to Map. Let's select both lines. Go to Edit, Merge, and here click on Merge. Okay, both lines are merged, but the fields were lost once again. Click on Save, and here on Map, select this one, Select by Attributes. So what the attribute selection does is select elements from various fields in a table, okay? So for this example, let's try to make a selection by attributes in the pathways, okay? So for this, you select New Selection, where surface is equal to gravel, okay? So if you see in this table, only the object ID number 1 will be selected, of course, because only the object ID number 1 has gravel as the surface, okay? Let's assume we also want to select paths that are not cyclable. So for that, I want pathways where surface is equal to gravel or cycle is equal to no, okay? So why do we choose or instead of and? Okay, let's imagine the following example. We have a basket with 3 apples, okay? One red in good condition, one green in good condition, and a yellow that is rotten, okay? If we use select basket is equal to red apple or basket is equal to apple in good condition, this command will select both the red apple and the green apple, okay? If we use the same command but with an AND, the result will be just the red apple, because the red apple matches both criteria, okay? Now let's clear the selection and use AND, okay? If we maintain surface is equal to gravel and cycle is equal to no, as you can see in our table, only one of the elements meets this criteria, okay? Now let's try to make a new selection where surface is equal to concrete. First, let's create the last selection. And preservation is equal to good. As you can see, only the object ID number 3 is selected. Let's try another one. For example, surface begins with G. This means that only the elements where the surfaces start with G, with letter G, are selected. So as you can see here, there's a lot of different selections you can make. Now let's learn a little bit more about the select by location. For that, I will create new elements. I will select the playground, hit on circle, and draw a circle right here. And now I will create some trees, and I will place trees near the playground and near our paths. Clear, save your edits, and close this table. Now let's suppose we work at Aalborg City Council in the area of civil protection. And we know that several trees are an imminent danger to people who visit this park. So the Civil Protection Department then decides to cut down the trees that are close to the paths and the children's playground. I'm just going to draw some more trees, just to fill more of our space. And now let's use the select by location to solve our problem. Let's start by creating a new field in the trees feature class. This field will be named, for example, cut. The type is short, and the domain will be the Boolean domain. Let's save. As you can see, all the values are null. First, let's understand which trees are inside the playground. For that, the input features are the trees. Use intersect for the relationship. Selecting features will be the playground. So here I'm just asking to the software which trees are inside the playground. 3 of the 32 were selected, 2 were inside and 1 was right on the intersection, so this one will be to the current list. Okay, now let's select trees within a distance of the playground and choose 10 meters as the minimum safety distance. So for the search distance, let's choose 10 meters. So as you can see, all the trees that are located within a distance inferior to 10 meters from the playground will be cut too. So let's change the value from null to yes here on the cut field, like this. And to finish, the department decided to cut trees that were 25 meters apart from the pathway. So for that, let's select trees within a distance of pathways, search distance 25 meters. Let's apply, and as you can see, a bunch of trees were selected. You can select this button to view only the selected elements, and you can start changing the values from null to yes, like this. So let's sort ascending, select all the other trees. All the other trees will not be cut, so you can select no, but to select the option no faster, we can actually right click in the cut field, select calculate field and say cut is equal to 0 because 0 is the code for no, like this. To finish this tutorial, I will show you a cool tool that comes in handy when we are working with data that has a lot of elements. So, for example, in my job, sometimes the client sends us streets shape files that were not drawn correctly. So, for example, different streets that are merged and should not. So a cool trick to improve our data is to use the Planarize tool. So I just merged all the streets together so you can see the power of using the Planarize tool. So for that you click here. First you need to select all the streets. In this case there's just one. So you click on Planarize and all the streets will be split on all the vertex. So you click on Planarize and as you can see we have all the streets split again. Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.